but I already know what kind of questions will be happen. Okay, we will have the probably 6 questions out of 5 for you to choose. With 6 questions for you to choose, so that you have to pick 5 in exam. One of that, Monte Carlo. Okay, and I already told you what you would have. Okay, what kind of question we'll have, and you will have the you will have probably 2 questions would be in gum, 2 questions in Eurochem. 1 question will be a mixed model. Okay, mixed model with difference. For example, you might probably will have 1 question. Some parts will have the t-test. Okay, to conduct the t-test. For the t-test, it might be for calculation of the for the bias, or for gum approach, you try to compute something. Okay, and so you will have the and also some definitions. Okay, might ask you some definitions. Might ask you some, what else? Yeah, some definition and also some scenario questions. Okay, text-based, not calculations, things like that. That would be a mixed questions. Okay, for different areas. But generally, we will have 5 questions. 2 will be isogum, 2 will be Eurochem, 1 for Monte Carlo. Okay. So, for example, this one, you might need to know the measurement. Okay, definition of measurement, and true value. Okay, definition for true value, and you know the random error and systematic error, how to compensate or how to minimize the errors. This diagram, okay, to draw that and then label that, and the definition of precision, accuracy, bias, repeatability, reproducibility, intermediate precision. This one is just for you to know how to do to keep the significant digit. So I won't try to ask you the rule number 1 for 0, rule number 2. I won't. Okay, just during your calculation, you try to keep the best practice in significant digit. That would be fine. Traceability. Okay, this definitions property of a measurement result whereby the result can be related to a reference through a documented and broken chain of calibrations, each contributing to the measurement uncertainty. Then all this would not be asked. Okay, I won't try to ask because I know someone tell me that there will be someone will ask you to memorize the period for cesium atoms. I won't try to ask you this kind of things. Okay, don't worry. Okay, just skip that. No for this one. Measurement uncertainty. The definition of measurement uncertainty would may do. Okay. This diagram. Yes. Okay. The relationship between error and measurement uncertainty. Okay. I might try to asking you what's the difference between errors and measurement uncertainty, and then you tell me that measurement uncertainty is actually the random measurement errors plus the systematic errors for the unknown systematic errors and the residual error from known systematic errors. Something like that. Okay? Or you try to draw me this diagram and something like that. Okay? And this you have to understand the assumption. Okay, the assumption described by number equivalent to variance. Okay, the measurement process are under control. Only all significant components has been accounted. Okay, and no correlation between components. Okay, this four assumption. Okay, and type A, type B, what are they? The difference between empirical method and rational method. Okay. Rational method is the test method to measure a property that is defined independent of any test method. Okay? And empirical method is the method intended to measure a property that is method dependent. That's it. Okay? Okay, that is for how to evaluate the measurement uncertainty, and I won't try to asking you the details in the text. You just evaluate from the Excel or calculator, okay, for me. Okay? So not too much to memorize. Okay? Okay, this is for partial differentiation. Okay, I won't try asking you what is product rule or whatsoever. As long as you know how to do the differentiation, then it will be fine. Okay. And I won't try to asking some model that require the chain rules, things like that. Okay. Product rule, quotient rule. Okay, and something that you encounter in the exercise would be the limit. Okay. Okay. Don't worry for that. Okay. I won't try to asking you chain rule. Okay. For the if you try using that approach, the estimations, okay, small increment approach to estimate the uncertainty, you just let me know during the calculations of the sensitivity coefficient. You just let me know you are calculating from using this estimations, the increment, small increment, and then telling me that what's the factors you use for the increment. Okay, for example, you use 1/10,000 then 1 over 10,000 of the variable, then it will be fine for me. Okay? And
我
the
要算费时间吧。
this table I will give it to you. Okay, maybe more complex, but what you need to know is that you have to use two tails, 95%, because the table I give you might have one tail, two tail. You have to use the correct column. Okay. This equation I also will give you the relative reliability. Reporting the maximum uncertainty. Okay. I might try to ask you to report. Okay. After you calculate something, then there might be a questions of about 2 marks to report the results with the uncertainty. So what will you going to tell me is that the length of the sample was 20 centimeters plus or minus 1 centimeters, and this sentence for 2 marks. The reported uncertainty is based on a standard uncertainty multiplied by a coverage factor k equals to whatsoever, providing a level of confidence of approximately 95%. That's it. Okay, this sentence. Okay.
不想写
Limit of gum approach. Okay, it mainly deal with linear and symmetric models, and so it will assume the resulting quantity is a student t distribution. Okay, and based on this, because it cannot deal with nonlinear and non-symmetric models, and it's assuming for some cases the final result is not a t distribution. So to deal with that, you may suggest to use the Monte Carlo methods. Okay, can be used for to elevate the limitations of the original gum approach. Okay? And the number 7. You understand the trumpet, the orange trumpet, that if the measurements, the values we will measure is lower down, the variation will be increased. Okay? And you also need to understand that what is mean of the control, okay? In gum, it's also required you, the assumption is that the measurement is conducted under a controlled environment, okay? What's mean of controlled is means appropriate qualified staff, proper maintenance and calibration of equipment, sufficient verification and storage of reagents, use of reference standard, documented measurement procedures, okay? That means define the man, machine, material, methods, and environments. Okay? And the assumption is the same. Actually, the gum approach and EuroChem approach, the four assumptions are the same. Empirical method do not have bias. Do not have bias studies. Only have the precision and the purity. and also some residual physical uncertainty. Okay, that's it. I won't try to ask you to draw this kind of fishbone diagram. Okay, no need. And you understand that from the chemical testings, the EuroChem approach only would have the reproducibility, which means the precision, recovery, homogeneity, and purity of standards. This four component, and you have to consider for example, the precision or recovery. You have to consider the low, medium, and high concentration ranges. And the precision studies, you should have to master how to deal with that. Okay. For precision studies, for bias studies mainly is you have to know how to do the t-test. Okay. That's it. Okay. And you still have one more exercise. I haven't tell you the solutions. Okay, so I will try to solve that for you. Okay. Exercise 3. In a measurement of trace metal analysis, the lab have shown that a recovery. Okay, so the first part is talking about the recovery. The recovery means of copper content in 10 samples of distilled water, okay, with 3.5 milligram per liter of CRM copper spike was found to be 3.65. Okay, so the population mean. Where's the sample mean? Okay, and the standard deviations of okay, and so what is the standard uncertainty of bias with copper analysis in water? So what you have to do okay. Okay, so we have the standard deviation equals to 0.18, okay, and it's equal to 10, and so the mean right, and so the standard uncertainty is equals to 0.18 divided by 3.65, which is the RSD over Okay? One thing you have to know is that for Eurocam, the uncertainty is a relative scale. So you have to convert the S into a relative standard deviations first, and then divided by square root n. Okay? That would be a unitless results. Okay, it's a relative scale. So the results here saying it is around 1.5, 1.6%. Two significant figures. Okay, about 1.6% or 0.016. Okay, for this. Okay, no units. And this one is considered when 100% recovery. But right now the recovery is more than 100%. Okay, it's 104%. Okay, so you have to do a t-test. Okay, t-test got an assumption that the null hypothesis, which is the mean. Sorry, this one is mean is this one equals to this one, and the alternate hypothesis is okay. And to do the t-test, you need to have the equations of t statistics equals to 1 minus recovery over the standard uncertainty. Okay, and so it's equals to okay, equals to 2.7. Okay, and so okay, you can take a look onto this. Okay, these equations, and if now the degree of freedom equals to 9, so you have to retrieve the degree of freedom. 9 is equals to 2.26. So you found the result is larger than 2.26, right? So back to the slides is that because the t statistic value is greater than that of the critical value, and so you have to apply the correction factors. Okay, so based on this, because the t statistic is greater than that of the t critical value, so conversion factors is required to apply. And so the uncertainty after the correction will be equals to the original uncertainty divided by so it's after corrections the uncertainty for bias okay, so that will be the answer for the bias. And then below you have two set of data, you have duplicate data, and so how you compute that? Okay, you will have the mean. Okay, so you have to adjust the okay, that is the okay, should be this one called 0, okay, so it should be 2 decimal point, and you would have the difference okay, and you will have the normalized difference mouse is not working very well. Okay, so that is the correct significance. And so what will you do? You have to compute the standard deviation. Okay? and the okay, you have the standard deviation of the normalized difference, and you will have the standard uncertainty divided by what? Square root what? 2. This one is the default of 2 because it's paired data. Okay, remember that. And so we have the standard uncertainty of this one. Okay, since it's a normalized data, so there will be no unit. Okay, no unit. It's also a relative scale, so it is about 7%, and the bias is about 1.5%, 1.4%, 1.5%. Okay, and so the next one, compute the table accordingly. What's the standard deviation of deviation and the standard uncertainty of precision? Okay, so here is the answer. And if the certificate of coupled solutions for spiking has stayed an uncertainty of plus or minus 0.5%, 95% confidence level, what is the standard uncertainty of the coupled solutions due to purity? So if this is the case, you are from type B. Uncertainty for the certificate, and the expanded uncertainty in the certificate is 0.5%. So it is 0.005 for 95% confidence level, and so you have to convert back to standard uncertainty. And how to convert? Divided by k. Usually the k is 2. So you would have the uncertainty of
sample 也是用这个 big U， device 那个 K， 通常是 H。
okay. Okay, only one significance. And so overall what is the combined uncertainty and the expanded uncertainty? So you try to combine the uncertainty. Okay, and so the combined uncertainty is equals to square root the standard uncertainty due to of bias square plus precision square, and then standard uncertainty due to the purity square. That is for no. That should be have 2 certificates. Why? Because you have tried to take the square first. Okay. This one, after taking square, would be okay, and the standard uncertainty to bias the square of that standard uncertainty to purity. So after you add, there should be 2 decimal places for the sum of that. After sum, the decimal place only have 4 decimal places. So if you do a square root, then you would preserve 2 significant figures. Okay, so the result is 0.072, and the expanded uncertainty is equals to the combined uncertainty times 2. That would be 40%. Okay? So that would be the answer for the first questions. And for the second one, you have another quality control studies of paracetamol content of different products lie in an in-house method with the data below. Okay, so you probably see the data. You should find that there are around 2 different levels. Okay, from the data, you will see this one is around 600 something. This one is around 500. This one is 500. This one is around 600. Okay, so you got 2 to 3 different levels. Okay, from the data, you can see that the different products would have different concentration. So to compare the standard uncertainty to precision, okay, you have to compare the average and okay, so that is the mean. Okay, the mean, when you try to summing the 4 or 5 data together, it will be change from values of hundreds to thousands. So you would get 1 more significant digit in the computing of the average. So you will see that I got 1 more significant digit in the average. And how about the standard deviation?
是什么？它是有显示在这个。
Okay, so that is the standard deviation. And if you have the standard deviation, you have the mean, you can compute the RSD.
我在那个 action 我已经这个可没有，因为
但是他没有跟我说他有一些，他只说那个我在。
可能还有同配的是这样的。
Okay, and so based on the RSD, you can then compute the RSD pool. Which means it is the standard uncertainty due to precision. Okay, is equals to square root this one times 3, the n minus 1, I forgot, is it square? You want it square? Square times 3 plus this one square times 3 plus this one square times 4 plus square times 4 divided by 3, 3, 4, 4. Something like that. Okay? I didn't actually quite certain to the formulas, but more or less the same. Okay, you can check that. And so the answer for that is n minus 1 times the RSD square plus the degree of freedom times the RSD2 square. Okay. So this is the standard uncertainty. Okay, the uncertainty of precision of this study is 0.0257. Okay, since it is already a RSD, so no unit for this one. Okay, and the final one is during the determination of bias, you have analyzed 10 replica of a certified reference material. Okay, the reference value, okay, means this one, 40.7. Okay, and where the mean and standard deviation of the analysis were found to be 40. So the mean you find is 42.0. and 1.83. With the assistance of below T table, determine which column, one tail or two tails should be used and whether the null hypothesis, sample mean equals to population mean, should be rejected. Okay, so in this case, we have to use the null hypothesis. Okay, the t-test, we do the null hypothesis. The null hypothesis we use is this one. And the alternate hypothesis is since usually for this null hypothesis, it's talking about they are like or unlike. So it can be smaller than or greater than. So there should be two tails. Okay, two tails. And normally we will use two tails until some points, like if you go to Sandra's class for doing detection limit, then they will be using one tail for some cases. Otherwise, most of them will be two tails. So, another hint during the examination, which column you have to read? This one. Okay? And so, you have the null hypothesis and alternate hypothesis, and then you do the t-test. Okay? So, you have the T statistics, or I try to type, that's equals to sample mean minus population mean divided by sample standard deviation divided by square root 10. Okay? And so you have the T statistics of, usually we will take 3 certificates for this case. 2.25. And if you go back to take a look onto that, when the graph freedom is equals to 9, is 2.262. Okay, so since it's smaller than that, you do not have null hypothesis cannot be rejected. Okay? Because of null hypothesis cannot be rejected, so they are alike. So the results would be, whether the null hypothesis should be rejected. Okay? Here, this question already gives you the hints that sample mean, the null hypothesis is sample mean equals to population mean. So it's definitely two types. Okay? And from the results, you would know that you cannot exclude, you cannot reject the null hypothesis. So they are no difference. Statistically, no difference. Okay? So, another hint test will be appeared in the exam for
比较简单。
the 6 questions.
我觉得他们都有比较难说一些
Okay.
点分的事。
So you now very clear on the exam.
太多
Okay.
背的了。
You're almost mastering this class. Okay? Any questions to ask?